Hi, my name is Vinicius Julião, and today I'm going to present Golang Channels. The concept behind Golang Channels was firstly introduced by Tony Hoare in his book Communicating Sequential Processes. This book was published on 1985, and despite this concept looks like something new, actually the CSP was already implemented in OCaml language. So the reason to use channels instead of other concurrency solutions or approaches is described by Effective Go book. The phrase that advises the use of Go channels is do not communicate by sharing memory. Instead, share memory by communicating. With this example, we will see what that phrase means. So let's observe. Here we have a program with two threads. Is a mutex or asymmetric based program. Alright, so imagine that this shared memory consists of an array or a hash table or a map. And generally, what we have to do with the shared memory is only use few elements of this shared memory and not the whole shared memory. Then why we have to share the whole memory between two threads? So now we can see a new approach that uses channels. In that example, we have a Go routine. This Go routine, we will call it as orchestrator. All right. So the orchestrator actually is the memory orchestrator. This thread is responsible to manage, to generate, and to pass values to the other Go routines, and these other Go routines will be responsible to compute something and will communicate with the orchestrator for the orchestrator store the value in the memory, right? So to understand what is Go channels, firstly we have to explain what are Go routines. Basically, a Go routine is a thread, and seeing this example, we'll see how to transform this example in a parallelized version, right? So here what we have is a function that given two integers returns the first returned value is the maximum value between both of these two, and the last returned value is the minor value. Alright, in the parallel execution, our main function have to create the channel that is created by makeChan, and this channel has a type that is an integer. Alright, and to run the function in parallel, we have to run this as a Go routine. Then the function call will be preceded by the Go keyword, right? So, and then the function, the maxmin function, will receive actually a new parameter that is the channel, and not will return values anymore, but will pass these values, the result between the channel, through the channel actually. So, alright. So, to understand unbuffered channels, let's see this diagram. Here we have two Go routines. Let's imagine two Go routines, that is the receiver and the sender Go routine, and a channel that will connect these two. Alright, so but notice that the sender wants to share an information that is this red bar with the receiver. The sender Go routine will try to pass this value, this information between the channel, but notice that the sender Go routine will be frozen until the receiver is available to read from the channel. And then after this writing and this reading, both of these Go routines are free to go. For a buffer channel, we have to specify the buffer size. In that case, we are using a buffer of size 1. So the channel buffer will works like a sender helper. So when the buffer is free, or when the buffer has space enough, the sender can only write the information to the channel and go on without waiting for the receiver. But in the case where the buffer is full, the sender wants to deliver new information, So the sender have to wait to the receiver, and then while the receiver is reading from the buffer, from the channel buffer, the sender can write the data, the information in the buffer, in the channel buffer. All right, but we have a general case. In that general case, let's imagine that the receiver coroutine is available to read before the sender is available, before the sender being available to send information, right? So in that case, it doesn't matter if the channel is buffered or unbuffered. If the channel is empty, the receiver will be frozen, will be stopped until the sender is available to share information through the channel. All right, and after that, both of them are free to go also. Now let's introduce two different examples. The first one is using an unbuffered channel, as we shown initially, right? So here, in the first line, we are creating the channel. This is an unbuffered channel, right? So the second line will run the max min function in a coroutine. So after that, when the coroutine, the main coroutine and the max min coroutine are available to share information, these two coroutines have to synchronize this traffic of information, this information traffic. All right, so these two lines will be executed sequentially, and also the next lines. Otherwise, if we don't have this synchronization, one of these two coroutines will be stopped. All right, so but a buffer channel, in that example, we are creating a channel with a buffer of size 2, right? And then when we run max min via a coroutine, we have two free spaces in the channel. Then our max min function does not have to wait the receiver. Now, as our last example, let's see the select statement. So when we are dealing with two or more different channels, and we have to identify, we must identify which channel finishes to run firstly, we use the select statement. So in that example, we are identifying if the full or the bar channels, which of them are is finishing to run firstly. And then what we are doing is just executing the coroutine for full and bar, and then passing the name of the strings full and bar to the channel. And then we are putting it in the channel, and the select statement in the main coroutine will be responsible to identify which of these channels finishes first. So that's it. Thank you for watching.